These lectures cover the concept of data mining and also data analytics. So our main objective is to go through what is data mining. In our previous lectures, we discussed about what is data mining tasks, and also their algorithms. So here we are going to do a very quick recap of what is data mining. Then we are going to discuss what is data analytics and also the spectrum of analytics. Then how data mining fit into analytics. So a recap here, what is data mining? We say the process of discovering patterns, insights, and knowledge from large data sets. The focus here is finding hidden, previously unknown patterns and relationships. We employ algorithm from machine learning most of the time, machine learning, statistics, and AI. So data mining use machine learning algorithms and some statistics and AI methods. The output is predictive models. Example would be the churn prediction, or descriptive patterns. Example would be a customer segment or association rules also. And the goal here is digging for gold or hidden treasures in a vast landscape of data. So here we can say that to understand how data mining and data analytics work together is very important or crucial to first define each term. So while often used interchangeable, they represent distinct yet highly interconnected aspect of data science. So next, let's go through what is data analytics. So the broad definition here, we can say that data analytics is the process of examining raw data to draw conclusions about that information. Also, it's a very broad field that consists of the entire process of collecting, cleaning, transforming, modeling, and interpreting data to discover useful information, also inform conclusions, and also support decision making. Yeah, decision making. So the goal here again is to make sense of data. We should make sense of data, identify meaningful trends, solving problems, and also ultimately drive better business or organization outcome. And the scope can be ranges from basic reporting to sophisticated predictive modeling and also optimization. And it's about, again, understanding what happened, why it happened, and what will happen, or what should be done. That's the main. So we can say that the method also used in data analysis can be statistics, visualization, reporting, forecasting, and optimization. So the spectrum of analytics, here we say that again, data analytics can be classified into hierarchy of increasing complexity and the value, increasing complexity and value. So for example, we have descriptive analytics, we have diagnostic analytics, predictive analytics, and prescriptive analytics. We shall go through each one. So with the descriptive analytics, the question will be what happened. The purpose here will be summarize and describe past events. Descriptive statistics, summarize and also describe past events. The method we can use in descriptive analytics can be reporting, dashboards, basic aggregations, visualizations, and also historical trends. So a good example here can be, let's say, quarterly sales report, number of websites, visitors last month, average customer spending or average customer age, etc. Yeah. The next one is the diagnostic analytics. Here, the question will be, why did it happen? So we are trying to diagnostic and why did it happen? So the purpose will be to investigate the root cause of past events. The method here, we can use the drill down analysis, data discovery, correlation, anomaly detection, often using data mining techniques also here. The next one is the predictive analytics. The question here will be what will happen, because a prediction, what will happen. So the purpose here can be forecasting future outcomes or probabilities based on historical data patterns. Here we use mostly machine learning. Example can be regression, classification, time series, forecasting. So machine learning models. And the next one will be the prescriptive analytics. Here will be, this is prescriptive. So what should we do? Prescribe. What should we do? How can we make it better? So the purpose here will be recommend specific action to optimize the outcome or achieve objective. The methods here can be, again, optimization, simulation, decision support systems. This method, again, rely heavily on the outputs of a predictive models, often built through data mining to provide, again, recommendations. So example can be recommending personalized product offers or optimize supply chain routes or suggesting the best treatment plan for a patient, prescriptive analytics. So those are our 4 major areas of, again, data analytics: descriptive, diagnostic, predictive, and prescriptive. So how data mining fit into analytics? So here we say data mining is a core component of analytics, particularly predictive and prescriptive. Also, data mining provides the advanced techniques and models that power deeper analytic insights. So how data mining and analytics work together? Here we can, the whole thing is a data mining, I would say, we can say that it's not separate. It's not separate from data analytics. It's a critical enabler and also powerful subset that provides the advanced capabilities needed to move beyond basic reporting a predictive or prescriptive insights. So data mining roles across analytics spectrum. One, we can say enabling descriptive analytics that's beyond basic reports. So descriptive analytics, data mining can discover descriptive patterns also, such as customer segmentation through clustering algorithms, common item sets through association rule that inform descriptive report and dashboard. Normally, we know data mining have 3 major, which is supervised learning or classification regression. Then we have unsupervised, which is clustering. Then also association rule. Those are the 3 major areas. So the next is the diagnostic analytics. As we mentioned earlier, also, we cannot divide data analytics from data mining. They work together. So here we can say that in terms of diagnostic analytics, here we say why diagnostic analytics often use read down, data mining's anomaly detection can help diagnose unusual events or root causes also. And also predictive analytics. This is where data mining shines brightest. So predictive analysis, we can do classification and regression. Classification model will predict categorical, while regression will predict quantitative or continuous value. So when we say categorical, we mean, for example, patient tested positive or negative. Customer is profitable or not profitable, yes or no. That's it. Predicting the price of stock, or let's say stock price or basketball height, will be regression continuous. So data mining, again, as we mentioned earlier, is not separate from data analytics. It's a very important, critical, and also powerful subset. So prescriptive analysis, here we say data mining predictive models are input to prescriptive system, which then recommend actions. So example, predicting high-risk customers, that's data mining, then recommending specific intervention strategies will be, again, prescriptive analytics. So we mentioned about examples. For example, association rule mining can reveal common product bundles. Let's say a customer buys bread, also may buy milk, which are, again, descriptive insight useful for merchandising reports also. So next section is the work. We say the workflow. The typical workflow shows, I would say, the seamless collaboration. We have data collection and preparation, which is foundation for both. We gather new raw data. After we gather the data, we have to clean, transform, and integrate the data. So both data analytics and data mining uses the techniques of data collections and also preparation. So again, both data mining and analytics always depend on a clean, well-structured data. So this phase involves gathering data from various sources, cleaning it, and the process of cleaning it, let's say, example, will be handling the missing values, the outlines, transforming the data. Transform will be, for example, normalization, aggregation, and also integrating it. Then next, we have the exploratory data analytics. This is in terms of analytics, it's initial understanding of the data using visualization or summary statistics and also basic patterns. This often informs which data mining techniques might be most appropriate. Then we have the data mining model building. This is the core advanced analytics, applying a very highly sophisticated algorithms to discover hidden patterns or build predictive models or identify distinct groups. This is where, again, the deep, we say, intelligence is extracted. The next will be the model evaluation and validation. So model evaluation and validation is part of data mining and also essential for analytics also. And here, what normally we are going to assess the performance, accuracy, the robustness of the developed models. And this will make sure or this will ensure that the insights are reliable for decision making. Then the next step will be the interpretation and visualization. This also fall on both sides, the analytics, data analytics, and also data mining. So translating the complex output of data mining model into understandable insights through dashboards, reports, and interactive visualization. This makes the intelligence, again, actionable for stakeholders. Then also we have decision making and action, the ultimate goal of analytics. So this will say the ultimate goal of analytics, decision making and action. And here we are going to integrate the models and insights into operational systems and continuously monitoring their performance, possible feeding a new data back into the cycle for modeling retraining. So now let's go through some of the problems we may face. First is customer churn. And the business problem here is how to reduce, again, customer churn. Analytics alone, we are going to use descriptive and also diagnostic. So here we say our churn rate was 10% last quarter. This is descriptive. Our customers who churn often had a lower service usage and frequent support calls. So here we are diagnostic. Also, we have data mining and analytics together in terms of predictive and prescriptive. So data mining will be building a classification model that will predict which individual customers are most likely to churn in the next 30 days based on their behavior, demographics, and service usage. In terms of analytics, we are going to use this list of high-risk customers to send targeted retention offers. So that will be prescriptive. Or proactively engage with them, prescriptive also. Then track the effectiveness of this intervention. And this will be descriptive and diagnostic. So next we talk about the retail sales optimization. And the business problem here will be to maximize sales and also inventory efficiency. So in terms of analytics alone, descriptive and diagnostic, we can say the sales of product X increased by 20% last month. This will be descriptive. Now, the increase in product X sales was mainly in region Y due to a promotion. So this is diagnostic Y. Then data mining analytics together in terms of predictive, prescriptive. Here our problem is retail sales optimization. Here in data mining, we can use regression to focus the future demand for each product and also apply association rule mining, such as the market basket analysis to discover which products are frequently bought together. And that's data mining. In terms of analytics, it's to optimize inventory levels based on demand forecast. So this will be prescriptive. Or design a strategy product placement and cross-selling promotion based on association rules. Also prescriptive. Then measure the impact of these strategies on sales. Now, what are the benefits? First, we can say the deeper insight and moves beyond simply knowing what happened to, again, understanding why and what will happen and what should be done. In terms of proactive decision making, we can say this enables organizations to anticipate future trends, the risk and also opportunities, allowing for strategic and proactive responses rather than, again, reactive ones. Also, the increased efficiency and automations also. So automate discovery of a complex patterns that will be impossible, or we can say too time consuming for manual analysis. Then we have a competitive advantage. Organization that, again, effectively combine data mining and analytics can gain a significant edge by understanding their customers, understanding the markets, and also operations in unparalleled detail. The next is the targeted actions, or we can say targeted and personalized actions. So this will lead to more precise and effective strategies, such as personalizing marketing campaign, optimizing resource allocation, and tailoring interventions also. Then always continuous improvement. So data mining models can be continuously refined with new data, ensuring that the analytic insight remain relevant and accurate over time, fostering, again, a cycle of continuous learning and also improvement. So in conclusion here, we can say that in essence, data analytics is the broad discipline of deriving meaning from data, while data mining provides the sophisticated tools and techniques to extract deeper, often predictive, prescriptive insights within that discipline. So data mining fills the more advanced stages of analytic spectrum, transforming raw data into actionable intelligence. So again, with that robust data mining capabilities, analytics will largely remain confined to descriptive reporting. Together, they form a powerful and indispensable partnership for unlocking the full potential of data in today's data-driven world or society. So that will be the conclusion of this lectures. Again, if you have any question, feel free to send an email. Thank you.